All right, so yeah, today we're going to cover the basics of surfacing. So we're going to do a little bit of 3D sketching. So similar to what we did before, except now we have to worry about points in X, Y, Z coordinates. And then we're going to start worrying about curvature, equation-driven lines, and dimensions. And if we have time, we will also do some airfoil design as well. Kind of getting into the aerodynamics a little bit. This file we have here, the guys made this morning during the workshop, basically taking dimensions of all of the key sections of Baby Shark, which is really, really great. It's going to be super helpful for us to go ahead and model the drone itself. So we're going to grab some pictures from this, and we're going to get the guide kind of going. Before we do that, though, I'm just going to do a quick intro into a few surfacing principles, and then once we get that done, we're gonna kind of split up the work for the cat a little bit, and I'll do a little bit in this, and then we'll meet back next week. Hopefully, when more of the team's available, we can do a live meeting. This is probably going to be the last recorded tutorial for a while, as we're going to be shifting into having live meetings with the team to start splitting up work and getting the CAD kind of going for the semester. Because we have quite a lot of structural work that's going to need to be done to the drone. A lot of 3D printed parts, a lot of cutting into the frame, a lot of CNCing that's going to be done this semester. So we want to get started on designing those parts. All right, so first thing is we're going to open up SolidWorks and start a new part. We're going to just grab a quick. I'm gonna open up the bike again. We're gonna do another part of the bike today, actually, for the surface modeling. So today we're gonna look at the seat. The seat is something that can probably be done using more traditional CAD methods. However, it is something that we can do with surface modeling, so it's something we're gonna give a go. Okay, so I'm gonna grab a few pictures just like normal from each side. I'm trying to grab a few dimensions from there. Surface modeling leverages the use of pictures a lot more because it's typically a lot easier for us to grab shapes from the surface for the surfaces from pictures than it is to actually measure. You can imagine, for example, here, if I want to measure this curve, I would have to go and measure, various intervals here to try to create like a curve. Which is quite a difficult task to do, and it's prone to a lot of error. And even if you do get the points, then you have to try to fit a curve to it, and you could have some error there from how the curve is fit. So it's actually typically a lot easier to create something like this just from pictures. So I'm just gonna go ahead and save these to a folder. Very important for surface modeling that you have the pictures from all sides for whatever you're doing, because you need to be able to create the shape in 3D, because we're no longer worried about looking at our, for example, if we look back at the pedal, we kind of look at it in a two-dimensional way and then kind of extrude it into the third dimension, and then we do some minor touch-ups. When we're concerned with surfacing, we're designing the entire model in one go, and so we can't kind of look at it from a one-dimensional look. We kind of have to look at it like holistically. We need to see every part of it, and kind of how it all connects together. Bike right. We're gonna have bike back as well. Give us some. We may actually need more views than this later on, but for now this should be good enough to get us going. I'm going to go ahead and pull up our SOLIDWORKS again. We're going to create a new sketch. We're going to go to the front plane, insert our picture. I'm going to do tools, sketch entities, sketch tools, sketch picture. This one. Take the right picture, put that in. I'm going to try to take the origin here, and we're going to try to align that with the center of the picture. Give or take, somewhere around there. I'll grab the dimension for this. Just gonna quickly check dimensions for typical bike seat. I'm just gonna grab something online. So right now I just basically Google what size are bike. I guess they're called saddles apparently. That's interesting. Did not know that. Okay, well, I see something that says about 8 inches, so we'll go with that for now. So 8 inches in millimeters is about 200. Okay. So what we're going to do is we are going to make this equal to the length. Okay, and then we're going to set the length equal to 200. Okay, so what we've done now is we've made this equation driven. This is something that we're going to need to worry about quite a lot, especially with surfacing, because sometimes you don't know exactly the dimensions for something. So for example, when we're working with our surface model, we may not know exactly what the curvature is. And so what might happen is when we go to, say, interface a part with a surface that we have created, if something doesn't line up in person and we remeasure that and realize that maybe our model isn't 100% accurate, if we try to go back into our model and make that one change, it's not going to propagate to the rest of the design, and it may require us to redesign the entire drawing. So what we want to do instead is we want to make everything equation driven. That way, if we do need to make any changes, we can apply that across the entire model very, very easily. So for example, the way we can do that, I have to refresh my memory on this, but in tools, equations, once you open that up, so it's in tools and then equations down here, right there. It'll pop up with this window, equations, global variables, and dimensions. So what this does is it allows you to apply global variables to any dimension that you can make. You can also do math with these global variables, right? So for example, if I know the length is 3 times the width, I could add a global variable called width. Width, and I can set it equal to length divided by 3. Okay, and you can see that it'll evaluate that. And so now if I set something equal to the width, it will calculate that based on the length. So I now no longer need to update the width ever. What will happen is if I ever change the length, it'll propagate that to the width as well. Okay, so I'm just going to go ahead and pop open a leaf again, our photo measuring tool. I'm going to grab the top view of our bike seat. Okay, so I know that the length of the seat we're going to say is 200. So that's this dimension here, right? This is 200 millimeters. So what we're going to do is look at the width here. Right there. So that's about 100. So it looks like the width is about 1/2 of the length, which is good. So we can actually just edit this to be length over 2. We're going to say okay. We're going to exit the sketch now. Now, note what we're doing here is we're creating a 2D sketch to insert these images on, and then we're going to actually create the surfaces in a 3D sketch. It's important we do it this way, and the reason why we do it this way is so that when we do our 3D sketch, we know that these 2D sketches here are aligned with the axes. So if I click space, you can see that this sketch image is going to be perfectly aligned with that dimension. What we're going to do now is we're going to try to align the next picture, size it up properly, and then align it with the top. This is going to help us kind of visualize where our 3D model needs to go. So same thing. Now we're going to look at the top plane. Okay. So we're going to create a sketch here. We're going to do insert. We're going to do tools, sketch tools, sketch picture. We're going to throw in our bike top. Okay. We're going to go ahead and pull this down to here. We're going to set this equal to width, right? And once we do that, you see it's already defined by the length, so we no longer have to do anything, and it's going to auto adjust that accordingly. So I know that the origin should be about here. One thing I notice now is that the orientation is wrong, which is okay. We should be able to fix this by changing that to -90 degrees. Okay, and now what we're going to do is just line these up as close as possible. So I'm going to look from the top view and try to align that center origin as close to the center as I can. Ooh, I do not know what's going on with that with that line there. That's kind of strange, but it is fully defined, so let's not touch it. I'm just going to move around again, try to get that as close to the center as possible. Doesn't have to be exactly perfect because we're going to mirror the side that we do just to make sure it lines up. But something like that looks pretty good. Cool. That's a little off on that dimension. Let's move it over. Alright, around there looks pretty good. So we'll take that. Okay, we're now going to enter in our back view. So we're going to exit out of this sketch. We're going to go to the right plane now. Create another sketch. We're going to go to tools, sketch tools, sketch picture. We're going to enter bike back. Okay, so check first that is in the wrong side. So I don't know if we can change which side this is on. Oh, it mirrors. Perfect. Okay. Great. So we know that this dimension here is also going to be our width, which is perfect. So we're going to set this here. It's going to ask us for a dimension again, so we're just going to set that to our width. Make sure you always include the equal sign here. This is very important as well. Because if you don't include this, what it'll do is it's going to set it to the current dimension of the width, not as a pointer to the width, if that makes sense. So what's going to happen then is whenever you change width, it's not going to update. It's going to remember what value width was when you first entered it. So make sure you always remember to put this equal here. Okay, so this is now going to be to scale, hopefully. Now if we drag it down, we should see should line up pretty well there. Just gonna kind of line that up around there. So we can see that that looks about right. The height there is about good. Dimensions make quite a lot of sense. Maybe a little bit further down. Right about there. Okay. So now we can kind of see our bike start to kind of take shape and bike seat. Go ahead and lock that in as well. So a few things you're going to want to do now is make sure you exit the sketch. You can see sketch 1, 2, 3. Right? What you're going to want to do with these is you're going to want to rename them. Okay? So it's very important that you do this. Let's say this is right side. This is our, actually should say front. Just match it with the planes. This is our top. And this one is our back. Okay. So you should see those. Good. Now, once we, as we go through this, we're going to be changing which of these pictures we need to see at any given point in time. And when we do that, we want to minimize the amount of, clustered kind of stuff on the screen. So what we want to be able to do is just actually hide these. Right? So if we hide them, you can see that certain things disappear, and it makes it much easier for us to do the work. We need those references there, but not all the time. Okay, so now that we have this is really good reference for us. We're going to start doing some sketches. The first thing we're going to do is we're going to create a 3D sketch. Okay, we're going to align ourselves with the top. So what we're going to do now is we're going to draw an outline of the outside of our bike. Okay, so we're going to try to get the outer curvature of the bike kind of built up. So depending on the type of CAD model you're making, it may change what tools you're going to use to create this. But the first thing you always have to do is kind of create an outline. So for us, there isn't really a lot of linear patterns here at all. It's very curved. You can also tell that there really isn't anything circular as well. So this tells us a few things. One is that it's very unlikely that we're going to have solid reference geometry. So we need to create that for ourselves, and we're also going to need to create a lot of curvature, and the curvature is going to be custom. It's going to follow this outer path. So a few things we're going to do immediately is we're going to trace the outline of this center bracket to make sure that we have something in the future that can be our reference to attach this to other objects. Okay, so we're going to put that hole there, put this hole here. These we know are going to be equal. Okay, and we are going to see, put a line between them, make this along the x-axis. Okay, and we're just going to kind of cut the difference here and try to get them both as close to being in the middle as possible. Okay, I want to take this smart dimension now. This is 19.77, so we're just going to set it at 20 millimeters. Find these as 5. So they're most likely M5 screws that are 20 millimeters spaced apart. We're going to grab a, what is the tool? Dimension. Okay, that should be good for now. We may have to add some other stuff in the future, but we can't do some of the stuff that I want to do right now, so we're going to do that on a 2D sketch after. So this is in 3D, but right now this is all along the top plane. So next thing we're going to do is we're going to add a spline tool. So I'm going to go back to our top view. So what we want to do now is do the outer curvature, and we're going to do the inner curvature, and then make sure we incorporate the back side here as well. We'll grab a spline. And so what we want to do with the spline is kind of like similar like the pen tool in Photoshop, things like that. You want to grab, or basically you want to put points down kind of where there's large inflections in curves, if that makes sense. So for example, at the top here, putting one curve right at the top there is generally a really good idea. And then what you want to do is see what section of the curve is relatively constant, and when it stops being constant, you want another point. So you can see there's almost kind of like an arc here, right? That kind of goes out this way. So I think right about here is probably good for another point. And then you see as I drag it, you can kind of see that kind of lines up more with the curvature. And so we can always change these. So you can leave this here for now. And we're just going to kind of follow that same pattern, try to get something that this looks pretty constant up to maybe around here. This is constant for quite a while, so we'll go to maybe here. Then it starts to curve down, so we're going to kind of follow this pattern down this way. Maybe out to here. Go again out to here. And follow around maybe to here. To here. To here. To there. Up there, down. Kind of just follow the curvature on the outside. Try to match the points around the symmetrical center line as well. What we're probably gonna do with this model after we do one side is we're gonna determine which side seems to be the more accurate one, and then we're gonna mirror that one to the other side. The reason we're going to do that is just so that we keep the model symmetrical, which is going to make it in the end turn out much better. Okay, so we can see that looks pretty decent. What we now have is once you complete the loop, you can see these little handles. I believe they're called Bezier handles. And what these can do is quite a few very important things. So the first thing is up here, for example, we know that this curve here goes from curving up to curving down. So at some point at the top here, there needs to be a point that has a slope. So if you imagine this as a graph in calculus, right? There's a curve that goes up, and then there's a curve that falls back down. At each point, there's going to be a line, right, which can represent the slope of that curve, that like kind of parabolic curve, right? We know that at some point, because of this inflection, that at the top there's going to be a point that has a flat, like parallel to the ground line of slope, right? So what we want to do is we actually want to take these handles, okay, at the top for this point we want to define as that point. That's the horizontal one, right? So we're going to take that and we're just going to try to make these handles horizontal. Okay, so we're going to fix this along the z-axis. Okay, so you can see it curved, it kind of jumped a little bit here. That's okay. We're just going to pull this out. All right. Why are you not moving? Okay. Okay, I don't know why that one handle doesn't want to move, but that's fine. We're just going to move from this side, and we're just going to try to line up the curvature a little bit more. This one looks pretty good. You can also grab the points and kind of shift them a little bit, which is good. This looks a little bit rough, so we're just going to pull this out a little bit. Keep in mind, whenever you make a change to the curve, it's also going to affect the curve behind it. So you have to be very careful with kind of how you adjust things. That looks pretty good. This follows quite well. This needs a little bit of work. We'll pull that in. Always go back and check, make sure you're not breaking anything else. See, this one's very off now. It's okay. Just gonna pull that in. Oops. You know, it's also always Control Z if your curves go a little bit haywire. SolidWorks does tend to do that sometimes, which is okay. This one's a little bit rough. Here, I probably might recommend an extra point. We're kind of getting a curve that looks pretty decent, so we can go with that for now. This point here, we're also going to want to define this as one that goes along the z-axis. Okay. So now what I'm going to do is just go ahead and draw a line that goes from the base all the way to the top. And I'm going to create this for construction at infinite length. This is just going to give us a reference geometry along the center axis. Okay. And so if we back out, we can see this is still all along the outer axis, which is good. We have that center line. However, this isn't really what we want. What we want is something that follows either the top profile or the bottom profile. In this case, we want the bottom profile because the bottom edge is the one that actually kind of reaches out this far. So what we're actually going to do now is, now that we've created the top view of our spline, right, which I think both sides are good, yeah. What we're going to do now is we're going to drag the points down to the bottom, and we want to kind of have them follow this curve as well. Okay, so we're going to find the points. We'll drag them down, and we're going to try to line them up to make sure that they're along the same point on this axis, but they're just down on the bottom. Always make sure you're looking at the correct view, so if you do accidentally touch something, just go ahead and make sure you fix that. Drag both sides down. Now, if we've done this correctly, which with surfacing you never really know, what we should see is, if we go back to our other profile, is we should see a similar profile as before. It may look a little bit distorted, but we should see the similar pattern, but we should see from a 3D view that this should kind of follow our curve pretty well. So if we go out, we can see, yep, our top view still looks pretty much the same, but now we can kind of see that this follows along the bottom profile of the shape that we're going for. Right? Which is good. Next thing we're going to do is just kind of fix the curvature a little bit more. So we can see here, you know, there's some spots that do not line up remotely with what we would kind of expect. So we're just going to grab our handles here and just make sure that the curves line up with what we want. Oops, SOLIDWORKS is frozen. Okay, so we can see the curvature is looking pretty good across the board. This back area is a little bit chaotic. Could probably spend quite a lot of time adjusting this center section here, but it looks pretty decent, and I don't really want to spend the entirety of our time trying to kind of micro fix these up, so that's okay for now. So that looks pretty decent. Okay, so now that we have our bottom view there, what we need to do is start to connect this into 3D. So what we need to start working on is the top curvature. So how do we build the curves that go across the top, right? So we can kind of think of this as like, we've built the bottom slice here, and we need to kind of think about how this would be extruded into the third dimension. So what we're going to do is actually work on these curves, right? So if we look at it from the back, right? And the back, we might need to adjust the back of this as well. This needs to kind of line up with the bottom of this. And so what we're going to need to worry about is creating a loop along a few different edges here that line up with this shape. Okay, so we're going to go to the back view. And we're just going to fix up the look of this a little bit. So this should actually be down here. This should be a little bit up. This should be towards here. This should be here. Just gonna correct this a little bit. Correct this a little bit. This we're just gonna drop down there. And keep making adjustments. Now, if we're doing this properly, we shouldn't be we shouldn't be changing the dimensions across different axes too much. So what we should see is when we pull back out of this view, hopefully the rest of our views still kind of align with what we want, which they do. The center one is looking a little bit rough though. I want to try to line this maybe up a little bit. Yeah, this one can be a little bit intensive on your CPU, doing this kind of modeling, so just keep that in mind. Be patient with SOLIDWORKS, it's trying. This last little bit here is going to be a little bit rough, so I'm going to have to do this from a few different dimensions. It's okay. I'm going to try to fix the look of the curvature from this side. The more you edit and fix it from each dimension, the more it should kind of eventually end up where you want it to. Sometimes you get some wacky stuff like this though, which is really not what we're looking for. This looks pretty good. Over here, this needs to be corrected. Okay, it's looking pretty good. Looking fairly decent from those sides as well. Just gonna pull this up to match there. Hopefully that doesn't miss anything up here. Yep, seeing some weird stuff up in the front here. Just gonna try to fix that. Not quite sure what happened here. Some other dimension may have gone a little bit crazy. It's okay. Just gonna fix this up. Okay, that looks pretty good. Alright, we're gonna leave it there for now. This is gonna be our bottom profile. Still a few glitches here and there. We can spend a lot of time correcting these, but I'm just gonna make it look fairly reasonable, and you guys are more than welcome to spend the time to continue with that. Just need to to make sure it's at least continuous. This can be a little bit frustrating sometimes when you get these situations where just geometry doesn't really want to cooperate with you. Surfacing, this is probably what you spend the most time doing, but I can kind of live with this, so we're gonna leave it there. Next thing we want to do is just exit out of this sketch. And save our document as well, so you don't lose it, especially with surfacing. It takes quite a lot of time to work on things, so make sure you try to save regularly. I'm just going to make a folder in here for our UAV, or TMAV rather. Just do bike seat. Okay, next thing we're going to do is we want to make another we're going to make a 2D sketch in this case. And so we're going to close the loop here. But what we want to do with this 2D sketch is we want to do it at the largest width here, so that we can try to take kind of like a slice out of the bike seat. So what we're going to do is we're going to do a reference geometry. Okay, so the first reference is we want to make sure that it's in line with the this plane here, so the right plane, to make sure that it's perpendicular to the slice that we're trying to create. And what we're going to do is we're going to find a point along our bike seat that makes sense. So about there is pretty good, but we probably want to be closer to here. So what we're going to do instead of that is we're just going to kind of hard code this as a distance away from it. I'll say it is 55 centimeters away, 5 millimeters away. The exact place you put these is not super relevant. The thing with surface modeling is unless you are doing something extremely precise, which we will not be worrying too much on this team, everybody should be getting a slightly different value for the surfaces that you make, and that's kind of expected. But when you're doing this as precisely as you can, the values that you get should be very close. So for example, when you take the CSWP, which is the Certified SOLIDWORKS Professional, the advanced variant of that for surfacing, some of the questions that will come up will give you a picture and ask you to create a surface model from it. And it'll ask you to estimate the mass of it. And every single person who does it is going to have a slightly different value because you are designing from a picture. You know, if you're even a pixel off, you're even, a nanomillimeter off, you're going to get a different weight value. And so what they do is they give you an allowance of about plus or minus 1% in grams, which typically, if you follow the curve as close as you can, you'll always come within 1%, which is pretty close. As far as engineering standards go, 1% of error is generally very acceptable. Okay, for now we're going to take this plane and we're going to go ahead and do a 2D sketch on it. We're just going to do a normal sketch. You also have the option of doing a 3D sketch on plane, but that's not really something we are particularly concerned with. Okay, so now that we have this, we want to make sure that our lines actually intersect this spline on the two outsides, right? So what we're going to do is we're going to do a spline again. And we want to make sure we have one point that's right along this. And we're just going to do that same kind of pattern. We follow the curvature around. But we want to make sure we're following the curvature around where the slice is, not where our not where the picture is, but where the slice is. So you kind of have to do a little bit of critical thinking as to where the points and curves are going to be. Okay, we're just going to continue this curvature all the way along and meet up with the other side. Okay, so now if we kind of look at this in 3D, you can see that this is kind of the type of slice we're looking for, right? You can say that's pretty close to what we're looking for. Okay. So next thing we're going to do is we're going to go ahead and create a few relations. So we're going to make sure that these are piercing. Okay. So this and then this need to, or sorry, this point in here you need to pierce. So now those are piercing. We're going to go through the back. Just check the curvature. It looks like the spline here has shifted, which is not good. So that we actually have to exit and correct. What we're going to do is go back. We're actually going to roll this back. So we're going to take this little, I think this is called a rollback bar, if I remember correctly. We're going to roll this back right before we did that sketch. What that's going to do is just remove everything we've done beforehand and keep it in kind of limbo. And so what I'm going to do here is just edit the sketch. Okay, so you see that this is completely off, so we're just going to drag this back on. We're just going to correct the curvature a little bit on this. Make it as close as kind of possible. Do the same thing on this side as well. There are more precise ways that you can build these splines, but this is just an introduction. You guys can spend lots of time messing around with this on your own projects to kind of understand how they work. I definitely encourage that you do so. Okay, that's going to bother me forever, but that's fine. So we're going to exit the sketch again. If we pull this back down, what it should do, right, which we can see is that it's now edited this sketch that we created, right? And just like the equations that we made before, it has propagated the changes that we made in this sketch through to the sketch that we've made. And even though it's a very complicated spline that we've created, it's actually followed that piercing relationship that we've made there. And so now it's scaling that spline with the other spline for the top view, right? Now we see this is starting to kind of take shape a little bit, which is good. Next thing we want to do is create a few lines that kind of intersect the top geometry of the left side here. So what we're going to do is kind of split it up into different surfaces now. So we're going to create a 3D sketch that goes from the back of this left side up to the top of this one and then out to the front here. Okay. So we're going to exit again. And we're going to create another 3D sketch. This time we're going to do it from the top view first. We're going to create a spline from the back here. We're going to connect it. Let's maybe do 1 point intermediate. Connect to the top of this spline here. Okay, should go back to the view. And we're just going to follow the kind of top curvature. You can see in this picture the way the light kind of shines along this edge. This is what we're going to follow. So kind of follow here. Try to keep the curvature fairly constant. We're going to try to line up the middle, and we're actually going to stop there. Okay, then we're going to add a separate spline that goes from here down to the front and exit. Okay, so you should have something that looks like that. Okay, so now if we go out, we should see that line roughly following some of the curvature we want, which is great, but we need to do a little of editing, which is okay. So we're going to make sure we're in our right view again, and what we want to do is just make sure these lines are following the curvature as much as possible. Might have to move your points a little bit just to get it to work. One of the first things you should do is try to make sure all your points are actually on the curve that you're looking for. You can see a few of them are below. This one we're not going to be able to move because it's connected to the top of our curve, but that's fine. What we're going to have to do is just kind of work around that. We're going to try to scale the back down just to make sure that the curvature looks smooth. Just for the sake of time for the people that are present here, I'm going to simplify the model a little bit, make it easier for us to finish. When we do our CADs for Baby Shark and any of the other drones that we do CADs for, and all the work that we do with surfacing, the expectation is for us to get this as perfect as possible. So please take the time when you are doing your CAD to sit down and make sure it is as correct as possible, because anything that you mistake in doing these steps is going to make interfacing parts later on much more difficult. Okay, so now that we have this, we can start to create our first curve. Okay, so what we're gonna do is we're gonna do another 3D sketch. Okay, and we're just gonna rename this one to, I guess you can't rename it until we started, that's fine. But what we're gonna do is we are going to use the Convert Entities tool. So all of these splines that we've created now are all reference geometry. These are not gonna be used for the actual surfaces that we create. The reason why we do that is because it can be very difficult for us to rebuild these and get them exactly the same. So what we want is wherever there's going to be separating geometry for surfaces. So for example here, we can see that there's a few closed loops here, right? There's this line here, or this spline here intersects with this one, and then this one, and then that kind of region within those three splines between here, here, and here, right, is where we're going to create our first surface. And so what we need to do is just kind of recreate that section, okay? So I'm just going to go ahead and grab this, and we're going to convert that. Grab this, convert that. Oops. Grab this. And we're going to convert that. Are we not on the 3D sketch plane? Sorry, hold on. I think I must have hit the wrong option. 3D sketch. I'm going to grab all three of these and convert. Okay, so we should see I think this is in 3D. I'm not quite sure what is going on with that, but we should be okay to create a surface from here. So the next thing we're going to do is we're going to go to View, and we're going to go to Toolbars, okay? This is something that I encourage everybody to make the change. There's a few ways that you can get access to the Surfaces tab. But what I'm going to do is just make sure I can actually see that. So it should be somewhere in here. Where is it? Surfaces, right here. Okay, so toolbars, scroll down. There is a toolbar for surfaces. So if you click on that, what it'll do is it'll pop on the left side here, the surfaces, all the surface tools. The other way you can get to it, I believe, is if you go to Insert and then Surface. You can see this menu here, which is useful. There's a few other ones. You can see there's Face, Curve, Reference Geometry, Sheet Metal, Molds, Mesh. Boss Base is also very useful. There's a bunch of useful tools in this Insert tab. But surfacing is something that we're going to do quite a lot of on this team, so and I make sure that we have all those surfacing tools available to us whenever we need them. So what we're going to do is we're going to create a boundary surface on this. So you can see there's quite a lot of surface types here. I'm going to briefly explain them now. You can go ahead and take a look into each one of them more, and their use cases can be quite broad. So extruded surface is you take a 3D sketch and you extrude a 2D plane that follows that sketch into one dimension. That's something you should probably just play around and see. If you're interested in how that works, I'll see quickly if there's a way I can test this along an axis. Don't think we have an axis right now, so we can't really do that, but that's okay. Maybe this one actually, hold on. I can extrude this against this line. Yep, so you can see that what that does is it takes the curve that you click and then it extrudes it in a direction, in a certain direction, and it extrudes everything in that direction, right? Pretty simple. Once you hit OK, okay, can't really do it because that's not you know, what this curvature was designed for, but that's how you would go about doing that. Revolve surface is very simple, or very similar to a revolved boss or base, but it creates a revolved surface around a drawing, around a center axis. Swept surface is the same as a swept boss base. Just creates kind of a curved surface around whatever pattern you're doing. Lofted surface is very good. You have two profiles and you can kind of connect them together. Very useful. Boundary surface is kind of the best and most robust one. It allows us to create extremely complex surfaces using intersecting splines like the ones that we've created here. There's also filled surface, which is when you have very simple geometry and you just want something that kind of fills it in. Planar surface is pretty straightforward, it's just a plane, basically like the side of a rectangle. Freeform is basically if you've ever seen Blender or, you know, any other kind of computer graphic design software that creates models that are a little bit more abstract, will tend to use freeform. It's also a very good way to add kind of realism to your design. So for example, if you're making a bike seat or a punching bag or a pillow or something that you don't want it to look too robotic or too computerized, something that looks a little bit more flowy and realistic, you can use the freeform tool to edit different points and kind of give it a wavy kind of structure or anything you want. Offset surface creates a surface with an offset related to another one. So use cases of this would be, for example, if you're making a car and you wanted to, I don't know, put a spoiler above the back or something, you could do that and then it would create the surface, and then you can cut the surface to kind of match the shape you're looking for. Ruled surface, that was a little bit tougher to explain. We'll deal with that one later. Delete face, you can delete a surface. So this is very useful for when we start doing more complex patterns as well. Whenever we want to say add a hole somewhere, we want to delete a face, we can change that face and then recreate the solid. We can replace a face, and then we knit surface. So knit surface is important because it allows us to take our surfaces and create a 3D model with them. So if any of you have ever worked with Google SketchUp before, there are some CAD programs that don't work with solids, but they work entirely with surfaces. And one program like that is Google SketchUp. So what you'll notice is if you ever export a file from Google SketchUp, it tends to be empty, and all of the outside patterns with it are just surfaces, right? Curved surfaces. And so these surfaces, what we can do with the knit surface tool is what it does is it takes the intersecting edges of them and it emulates what that would be if it was a solid, and then it fills it in as if it was a solid, and then you can apply any other CAD tools to it as if it was a normal solid. It's important to note that normal CAD tools, like anything in these features menu, will typically not work with surfaces. Surfaces are kind of unique. They need to be handled differently. There are some things that do. So for example, mirror, patterns, intersections, reference geometry will all work, but anything related to holes, cutting, sweep cuts, fillets, drafts, shells, any of these things will not work on surfaces. Okay, so the next thing we're going to do is we're going to grab the boundary surface tool. We're going to play around with this a little bit. So what we're going to do is try to create this back surface here. And so we have this direction tool. So we're going to grab this as direction 1. And we're going to try to select an open loop from here. Oops. Interesting. That did not work. Yeah, so sometimes you need to play around quite a lot with this. So you can kind of see here we're getting some of the shape that we want, but it is extremely distorted. Let's see, there's a better way to do this. There it is. Okay, let's do this surface now instead. Surface modeling sometimes is dealing with a lot of problems that are not always the easiest to solve. So what we're gonna do, yeah. So SOLIDWORKS doesn't like when you try to make surface models with long splines that kind of connect to each other. So for example, because both of these splines are in the same sketch, it considers them one when we try to connect them. So instead what we're going to do is we are going to exit out of the current sketch. I don't know why this is sketch. This is weird. To rebuild. No. Okay, we're going to remove that sketch. And we're going to separate each part that that's surrounding. So we're going to create the surface along this edge here. And so we need to separate each face of that into our different models. So we're going to grab this, we're going to convert that and exit. We're going to grab this one, we're going to convert that and exit. I'm going to grab the bottom one, I'm going to convert that, exit. And then we'll grab the top one, convert that, and exit. Now before we continue, these four are the reference ones for this model. We're going to be very careful that we don't touch any of our other surfaces, so we're actually going to go ahead and hide everything else now. We can hide this as well. Okay, so this is where naming things is starting to get very helpful because we know what our reference geometry is. Okay, so we're now down to a very simplified version of what we're dealing with. Okay, we're gonna see if this works the way we want now. So we're gonna deal with these two, and then we're gonna try to connect the directions this way. No. Okay. I was hoping that would work. Sometimes you need to do a little editing. What we need to do is just edit this line. Recording. Okay, so what we need to do is we need to split these sketches to allow us to just focus on the area of interest. So what we're going to do is go into Sketch Tools, click on the line, Sketch Tools, and Split Entities. Okay, so what we're going to do is we're going to select the section of the spline that we care about, and we can kind of ignore the rest. Now, it's not important that we include exactly this point, for example, even though we only want this section of the thing. What we really want to do is just get rid of the closed loop. So what we're going to do is just click on the outside of this and make sure we go around, and we're going to click on the opposite side of there. Okay, so when we do that, you can see that now when I highlight these, they're separate entities. Okay, I'm going to exit and just make sure I delete that side. Okay, so I'm just going to do this again just to make sure this side is also separate. So we should see, yep, there. So if I select this now, I should be able to delete that. Great. So now what we have is we have a section that intersects this side. We have a section that intersects this side. If if we exit out, we now have that bottom side, which is okay. What we want to do is edit this one now. I'm going to do the exact same thing. Sketch tools and split entities. Okay. What we're going to do is just grab from here to there. We're going to delete this side. Okay. So now we have those curves. We can exit out. So what we now have is we have this curve pattern that we want right here. Okay. So now if we go, we take a look at some of the different models. So we can do a filled surface, for example, which we'll grab these ones here. Okay. And if we be able to do a mesh preview. Okay, so we can now see our mesh preview. This is what it's kind of looking like. You can see that there's a little bit of distortion there, which is okay. We're missing a little bit here, but that's fine. We're going to fill that in when we do the next curve on that side. These zebra stripes are also very good. They allow you to check for tangencies in your curves. So what you really want is you want all of your curves to be very smooth and seamless. So you can see here, everything looks pretty good. What you will see is with some really sharp lines and stuff like that, something similar to here, but it'll look very jagged. We'll take a look at that for that as well when we continue on by connecting the other sides of this model as well. So we're going to allow this to go through. We can see that we now have that surface of the side of the bike pedal that we want. All right, so we can see that that surface is kind of what we're going for. I'm also just going to go ahead and back up and then try this with the boundary surface as well. The boundary surface allows us a little bit more control, so we can select the front and back sides, and then we can select the kind of longitudinal sides. All right, and so we can see this actually continues all the way to the back there, which is kind of a little bit more what we want, but we can also grab this and choose exactly what point that it stops at. So we're going to do that here and just make sure it's aligned with what we want, which is good. There's a few other things we can control, which is the edge conditions. So you can take a look here, zebra stripes and stuff all look good, which is great. We know that the front here is going to be a tangent relationship, so we want something that is normal to the profile. Okay, so that's going to make sure that when we connect the other side, that there isn't kind of a bump there, right? So some of these you can't really do much about. The longitudinal ones you should be able to do normal to profile as well. Okay. This side, we're not going to be able to do that, which is okay. We're just going to leave that as none. We click OK, we should see a very similar surface to what we had before, which is good. Okay, that's exactly kind of what we're looking for, which is great. So what we're going to do now is notice that in our boundary sketch, all of the reference geometry that we pulled has now been sucked into this boundary, right? So it's really important at this stage that we note that if we close this, we now no longer have to worry about any of those temporary sketches that we made kind of clogging up our hierarchy. So we can release those back. And now what we're going to do is we're going to go back and show all of our other sketches again. Okay? Great. So now we have one side of that bike. We're going to go ahead and start filling in the rest. So the next thing that we want to do is maybe touch this corner here. Okay. Perhaps before we do that though, let's connect the center as well. We're going to connect the center. Just get the top view back. So what we want to do is connect this line through here, up and over, and maybe connect it over to that, so that we can kind of create the side of this, and then we can eventually mirror it over to the other side. I'm going to blaze through this last bit a little bit quickly. I've kind of given you an introduction at this point to how to do surface modeling. The next step is for you to kind of do the practice, so I'm going to go through this a little bit quickly so you can see how I do it. And then it should be up to you guys to actually do some practice yourselves. You can do surface modeling on any part. You can make, a cube out of surface models. You can create a water bottle. You can create anything you want out of surfaces. So it's very good practice for you to understand how these work, because they can give you a lot of flexibility in situations where traditional CAD might pose some difficulties. Okay, but for now, I'm just going to blaze through this. I create a spline. Exit the sketch. We're going to make a new 3D sketch. Create another spline here. We're just going to start from here. I'm going to go this way, this way, this way. Let's do here and here. And then we want to maybe fix these a little bit. Looks pretty good. Let's go ahead and grab our right side view. Yeah, right side view. Grab our front picture. Just help us out with the curvature a little bit. So we know this is going to look something like that. We put this up here. We're going to want to map that up there. I want to make sure this is around the center there. Just going to be following this inside pattern, make sure that we're not accidentally adding random coincidences. Okay. Look at it now, I probably want to bring these down a little bit. This is probably more so down here. Yeah, so this is up, this is going to be down. The rest of these we're going to match around here. Don't know what's going on there. This is very strange. Just gonna have to pop back in. There we go. Okay. I create this kind of looking curve. This back a little bit. Yeah, that looks kind of like what we're going for. Just gotta fix this again. Okay, yep, that looks pretty close to what we're looking for, which is good. Exit it again. Just gonna fill in the top side there. So one more 3D sketch. Just gonna connect a spline from here to there. Then look at the right side. We'll smooth this out a little bit, and then we will get back to surfacing. Okay, so next thing we're going to do is create all the reference geometry we need for this side here. Luckily we have most of it, so what we're going to do is create a... Actually, let's see if we can do the cheap method of grabbing this, this, and this. Nope, Looks like SolidWorks doesn't like that. That's okay. So let's grab a 3D sketch. I'll grab this, convert, exit, grab the bottom one, convert, and exit. Okay, and then we're just going to go ahead and hide all of these. Okay. Okay, need to leave this one for now. I need to make sure we have this angle. So I'll make one more 3D sketch. Make sure we convert that. Great. I'm just going to pull this up a little bit so we can see this while we're editing our other sketches. Same tool as before, split entities. We're going to split from here to here. I'm just going to delete this and delete that. Exit out, and then we're going to want to edit this one. We're just going to split this one again. From here to here. Delete this. That as well. Okay. Now we're going to grab our fill surface and just fill these in. Okay, we can see there is a really strange boundary here. I'm going to make sure that's not happening, so you need to be a little bit more careful with this one. So let's try doing a boundary surface. Boundary surface doesn't want to work either. This may be a tougher one. Yeah. So the other thing we can do here, which is a bit of a tougher one, is we're going to go into this sketch and we're going to split this again from here to about here, let's say. We're going to exit out. And try to do another boundary surface. We're going to try to select the closed loop. Okay, so I've gone ahead and done something a little bit strange, but what I've done is I've allowed this face to be created with this kind of strange anomaly. And the reason I'm allowing this at the moment is what we're going to do is we're going to use this outer face. Because you can see this outer edge here has been created, okay? What we're going to do is we're going to use this edge to create the inside loop of the seat. And so what we're going to do is after we've done the inside loop here, we're going to go ahead and come back and fix this. So this is going to act as a way of, as kind of an intermediary step. I know it looks a little bit strange, but we can go back and kind of change that after. So it's not too big of a concern at the moment. We can delete the face and then kind of replace this after, but it being there allows us to kind of just create the next section. We can go back and kind of change that later. Sometimes with surfacing requires you to be a little bit creative with how you solve the problem. So this is just kind of one of those steps. So we're going to try a boundary surface between these ones now. Oops. Forgot I have to go and trim this one side here, so I'm going to go back into the sketch. Once again, sketch tools, split entities. We're going to split from here to, I'll say there. To there. Okay, we're just going to delete this outside. We no longer need it. I'm going to create a boundary surface from here to here. Oops. From this edge. SolidWorks is frozen again. Nice. And it crashed. Lovely. Alright, welcome back. So unfortunately, SolidWorks crashed, and I was not saving my work regularly, which obviously is a mistake. So in SolidWorks' infinite wisdom, it has deleted the last, give or take, hour of surfacing modeling work that I've done, which is great. So what we're going to do is, just so I can show you the last couple tools that you'll need to use once this is done, instead of finishing off the bike seat as it is here, I'm going to go ahead and create a more simple surface model and just show you a few of the tools that you may need in your surfacing adventures. Okay, so what I've gone and done here is I have created a planar face. Okay, so this is on our top plane. Just a simple square, kind of a rectangle more like. And I've gone ahead and created an offset plane, 50 millimeters out. Right, it's offset surface here. This is the same exact profile as the one below, but projected out 50 millimeters. If you have a curved surface here, it'll project the curved thing, so it'll be a larger size, but the projection of every point out by that amount. So this is 50 millimeters out. So I'm going to do now is I'm going to do a lofted surface. Okay, so I'm going to choose the top and bottom profiles, right? What this will do is it's going to connect every point around the profiles. Okay, so if I hit OK, you can see now I have this box. Okay, so just as you kind of extrude a 2D box. But something that's very important to note, and a tool that's good to see, is you see this little, here it's kind of like a half donut. It's called a section view. So if we do that, right, we can see that that our box is hollow, right? You can kind of take a look, and you use this as like a diagnostic tool to kind of look through your part. You can see as soon as you get through the edge there, you can see that this is a hollow part, right? That's not good. So what we want to do is we want to create this into a solid part. Before I do that, I just want to show you, for example, fillet. Right, you can't really fillet the edges of the surface. You can't even really select it, right? So laminar edges cannot be filleted. The reason for this is SolidWorks and most CAD programs treat surfaces as independent entities. You see if I click the edges here, it doesn't select the entire box, it selects just the surface. If you kind of zoom in enough, you could probably even see that the surfaces don't technically connect. There's a little bit of a line for both sides, right? So instead what we want to do is we want to knit them. So this is the tool I mentioned before, knit surface. If you click this and select everything here, right, you can go click one by one as well, but you can see what I've selected is surface loft 1, surface offset, which is the one on the top, and then surface plane at the bottom, right? So a few things you want to do, you can check for gap control, and it'll show for any gaps in the model. So this is especially if you're doing things by hand and then trying to knit them together. You want to check for gaps and stuff as well. But for a model that we simple like this, we shouldn't have to worry about any gaps. What we're going to do is create solid and merge entities. Okay, so when we hit OK, now, right, this looks a little bit more like a solid. Now you might say, well, that looks exactly the same as before, which is why our section view tool is so important, right? You see now that we've created a solid and merged the entities, you can see that our model is entirely solid, right? So now you can see that from the surfaces we've created a solid part, which is really useful. We can now go ahead and, for example, treat this as a typical solid body, and we can make a cut from it. Okay, so there you go. You cut it through, and now this itself is another surface that is protruding into this section. Okay, next thing I'm going to show you is the delete face tool. The delete face tool can be used to replace a specific face. So for example, this one here, you can go ahead and delete that. All right, sorry, just delete. So what that's going to do is change this from a closed solid back into surfaces, right? So you can see the cylinder there kind of touching up the cylindrical face from the cut. So you can see kind of the inner workings of how SOLIDWORKS treats all of its parts. It really just considers it a bunch of surfaces that it kind of knits together, right? I can also see there for a second when I was hovering the reference geometry of this. There's a line to the center. Interesting to note. Next thing you can do is you can also do, for example, a planar surface. So you can click the edges here, right? And you can create a planar surface, which is quite interesting. Now, it's important to note here, right? We've done a planar surface, which will match what was there before, right? If we do that, okay, great. But you can see that SOLIDWORKS doesn't exactly do what you might be expecting, right? Because now what we have is we have a hole through the bottom up into, you know, a place that's not there. So how do we fix this? Well, there's a few things we can do. One thing is that we could use the filled surface instead, where we could select this inner circle and it would actually subtract that from the larger plane. Okay, that's one simple way. The next thing we can do is actually we can do a trim surface. Okay, so what a trim surface will do is you can take two different surfaces and trim them away from each other. So what we're going to do is we're going to do a standard trim. Okay, so we're going to select this, and then we're going to select this face. Okay, sorry, before we do that, it's important to note what we have to do is actually to extrude this cylinder into let's see if we can do it along this edge. If I click this and extrude. Okay. I was hoping I could kind of cheat there, but no. I have to do this, unfortunately, the legitimate way. So what we're going to do is we're going to go up to the top and we're going to create a sketch on this. Okay, and what we're going to do is we're going to select the inner cylindrical face there and convert entities. I guess we can use this edge. Okay, so matching what was there before, we're going to do an extruded surface. We're going to do this through all, no, we're going to do mid-plane, and we're just going to extend it out. The size does not matter. What we want here is just to make sure that the object that we're using to trim our planar surface intersects both sides, okay? So what we're going to do is select them both, and we're just do trim surface, and you can see we can select which part we want to remove. So what I'm going to do is click remove selections and hit OK. Okay, so you can see now that that face that was there is now gone. If I hide this, we no longer need it. You can also suppress it. Actually, you cannot suppress it because it's being used in a feature. I apologize. You can hide it. And now we can see we have this planar face back, right? So that's the knit and knit, delete tool, offset tool. You can take a look at freeform. You can click on this, for example. Okay, I don't know why we can't do the top. That's a little bit strange, but I guess it's because there's a cylindrical or a circular exit there. But we have continuity there, but we can kind of like create a few different points, so we can add curves. So what we can do is kind of add these lines across here. Okay, and then we should be able to grab these, and we should be able to do some curvature with them, right? So this is this is freeform. This is the way you can kind of create more natural, flowy kind of objects. You know, things that typically you wouldn't see come from a more engineering style CAD. But for more aesthetic CADs, sometimes you want to design something intricate, something interesting, something artistic. You know, add some depth to your design. Say you wanted to build a house, or add some backdrop to some CAD that you're doing. You're building a bridge, anything like that. It's gonna look a lot better if you have a little bit of free form in it. So you can see that that looks pretty cool. It's a little bit more curvy, and it looks a lot more natural than a lot of things from CAD will look. What else can we do? We can use fillets and stuff, which is all pretty normal. We can also untrim surfaces, so it just kind of undoes a patch from something. Again, I'm just going to ignore a few of these. Swept and revolved surfaces as well. You can take a quick look at those. Just grab this plane. What we're going to do is just go over here. We can create something like this. So this will be our reference. And then we can create maybe something a little funky, maybe like that. Okay. And then what we do is we can do a revolve surface. It's exactly the same kind of parameters that we had to give it as the revolve solid. You can see and create something like that. Why not? Why are you not able to do that? Okay, that was extremely strange, but that's okay. You can see just there's a mirror effect on the ground. Just ignore that. But yeah, created this kind of donut looking shape, which is kind of neat. A few other things you can do using the surfaces, for example, is you can if you go back into insert boss base, you can do, for example, a thicken function. Okay, so what we can do is if we click this, what we can do is choose the thickness. So typically we want to do a thicken both sides. Let's say we want to do it by 1 millimeter. This is another easy way to create a solid. So instead of having to do knitting, you can also do thicken. Okay, so what thicken does is it takes that profile and it just extrudes out either side by a certain amount. This is now a solid, right? How we can tell again is by our section view. So if you look through, you can see that the inside is that white color we expect versus our cube over there, which we haven't knit back together, which is not a solid, right? So if we cut this to the side, you can see very clearly that's a solid. So now it's a very simple way to create solids. Keeping in mind all of these different tools and stuff like that will help you out quite a lot. One last thing I wanted to demonstrate as well is tools. Let's do a sketch on the front plane. Do tools, sketch entities. Do an equation driven curve. So I don't know, yx. Oops. I'm gonna grab an example of one that's interesting. Okay, so let's grab this one. This is probably an interesting one. Okay, we're just going to set the this is like 100. SOLIDWORKS is crashing again. You can see there's a bit of a sinusoidal curve there. Oh, there we go. Kind of a sinusoidal sawtooth. That would be incredibly difficult to do with splines. So if we are able to create sinusoidal curves to predict a certain pattern or whatever it is, could be useful to do that. This is also extremely important for airfoils. So when we start getting into doing the wing segments of Baby Shark, the way that we do the CAD model for the wings is we want to import the airfoil either by equations or by points. So I think there's a method in tools as well here where we can import, should be able to import, there's a lot of things we can do. Keep in mind you can also scale things, copy them. Scale is also very important. If you ever, for example, need a propeller just for aesthetic purposes, you don't want to design one from scratch, you can grab one that's on the market already that's similar proportions, and you can scale it to the size that you need. What else? Sketch entities. I have to get back to you guys on how to import the airfoils. It's been, I think, about 3 years now since I've had to do it, but it is something that we need to keep in mind. It's very important for doing airfoils and wing structures, so please keep that in mind and try to practice the surfacing a few times. It can be a little bit tricky to get your kind of head around. It's very, very, very important. Now I can show the the surface extrude here. Kind of looks like a corrugated roof or something like that. But yeah, please give these tools a try. There are a lot of applications for why we are going to need all of these tools. So please keep that in mind, and we're going to start getting started on the CAD. The measurements that were posted, the Faraz sent me here, these are going to be the ones that we use for the CAD model. So you guys are welcome to go ahead and see what you can do in creating these. I don't know if there is all of the really information you need. What we really need is some better pictures from each angle for these to help out with doing some of the surface modeling. Some of this is also things that we're going to want to do in solid body surfacing, or sorry, solid body CAD as well. So for example, this interface here, so this box section here is something that we're really going to want to interface exactly with the wing to make sure that these kind of line up in real life. So we're going to make sure that those are kind of perfect. I'll show you guys some tricks for that as well. But for example, one tool we mentioned, thicken. Thicken would be a very, very good tool to use for this cabin. Is for us to do a surface body model of this and then have to fill in the inside without, kind of removing everything that's on the inside, worrying about all these holes and stuff like that. We can actually create all those holes, all the things that we need to do, this hole here, and we can just kind of thicken it, and it will remain the same dimensions, and we can kind of just make it ever so slightly bigger, but the dimensions of the thickness of this will match what is kind of there in real life. And what we can do is we can thicken it from the outside in. That way the dimensions we read in real life will be accurate on the outside, and then we extrude by the certain amount towards the inside that the drone actually is in real life, and that way we can pull dimensions from the inside as well. Okay, yeah, thanks everyone. Please make sure to practice this. I encourage you guys to try to take a look at maybe CADing part of the drone, maybe taking a look at doing GPS unit. Maybe somebody could take a look at doing the pitot tube, right? This air sensor here. What else do we have? Somebody you definitely can get a start on the Baby Shark body as well. There's a lot of useful dimensions there, right? Motor mounts. Maybe you don't use this picture. There's lots of useful information there, so definitely get started on these, and we're going to meet up on Tuesday in the workshop and we're going to assign out some of these things out. Okay, thanks for watching.